Okay, in this video, I want to go through a typical vertical ground reaction force for running. And the different types of parameters that we would identify to analyze. So on the y-axis, we have vertical ground reaction force in units of newtons. On the x-axis would be time. And this would be stance. So the time that the foot is in contact with the ground. And for running, the stance time is influenced by running speed. The faster you run, the shorter that period of time is. It can be 0.2 seconds, maybe 0.25 seconds if you're running a little slower, maybe 0.19 seconds if you're running faster. So that stance time is influenced by how fast you're running, but it's a pretty short period of time. Less than a second, less than half a second, probably closest to about a quarter of a second. So I'll put 0 here, and I'll put 0.25 seconds just as an example. So EG, for example. All right, just to give you a sense of how short this period of time is. The foot strikes the ground here. The foot leaves the ground over here. So we would call this ground contact, GC, ground contact. And then over here, we would have takeoff or toe off. Either way is fine, and I go back and forth on both of those. So this is the moment the foot strikes the ground. This is the moment the foot leaves the ground. I'm using ground contact because people may strike the ground with their heel first. They may strike the ground with their forefoot, or we say toe, so I better put that in quotes. Heel, maybe a mid-foot strike, where the front part of the foot and the rear part of the foot strike the same time. Those are the three general categories of ground contact that we consider. And there's some intricate details in each of these in terms of where the foot is hitting the ground on the heel. Usually it's the lateral rear part. Generally, there's about 80 to 90% of the runners will strike the ground with their heel first. The others will be a mixture of forefoot and midfoot running. So I better put forefoot here as well, just as another way to refer to this. Forefoot, the front third of the shoe. This obviously is influenced by running style. You may choose to run heel first. You may choose to run toe or forefoot first, or you may choose to run midfoot. So this takes a lot of training to change the way that you run. It's not easy. Sometimes it's easy to do it for a few ground strikes, but then as you run further and longer, or maybe as you start getting tired, you may naturally gravitate back to what you normally would select. But these are just examples of ways that you can contact the ground. This curve is probably most typical for a heel striker, maybe a midfoot striker, and maybe sometimes this type of ground reaction force would be seen in a person who uses a forefoot strike as well. So let's go through some of the parameters. Ground reaction force on vertical ground reaction force on the y-axis, time on the x-axis. One of the first things we identify in this type of profile is this peak right here. This is local maximum, and we call that typically F1. Or we'll use the phrase impact force. This is the force right after ground contact, and this time here, this time would be about 10 milliseconds. All right, so 0.1 seconds. Oh, sorry, 0.5 seconds. So 0.05 seconds, sorry, 0.05 seconds. So very short period of time. 10% of stance, okay, is around this window. And This time that the peak occurs is influenced by a number of things. How fast we're running is one, our foot strike is another, maybe how much knee flexion we may have, things like that. But this impact force and the time that occurs are parameters that we'll typically identify in a ground reaction force profile. And that's a 0.05, so 50 milliseconds is a typical impact phase that we look at for running. All right, so impact force. The other dominant discrete force that we identify is this one right here, F2. Now, there are times that this magnitude of F1 is greater than F2. The way I've drawn it, it's less than F2. But this can be larger than that. This is just a typical ground reaction force curve that I would start with in terms of guessing what the curve would look like. And I'll show you some data in another presentation on some other ground reaction forces. F2 is occurs about mid-stance, so about halfway through the stance phase. And sometimes we call this an active peak. And then if we use active peak here, we may call this, another word for phrase for this would be passive peak. I don't tend to use these terms, but you do see these in the literature, and so they're not bad terms to at least be able to recognize. All right, so F1, that first peak, F2, that second peak. If we see a ground reaction force profile that does not have this impact peak here, we would still call this F2. All right, this is the greatest force at mid-stance is F2, and we always call it the second one, even though sometimes we don't see that impact peak. Okay, another parameter that we find really important to analyze is the loading rate. The loading rate is the steepness of this force curve, force versus time plot right here, in this impact region before this impact peak that we see. So what we do is we calculate the slope of that line, and the slope of that line is loading rate. All right, so I'm going to write that right here, loading. It's how fast force is increasing in this region. There's a number of different ways to calculate it, but in essence, that's what all you're trying to do is figure out the slope of some portion of this curve, anywhere between this peak and contact. Some people actually calculate the whole slope. Some people look for little individual slopes in here. Some people look at a specific time range. But in any case, loading rate is an important parameter that describes how fast force is increasing. Now for running, we don't typically calculate loading rates anywhere else, but we could calculate a loading rate here, unloading rate here, or loading rate here, unloading rate here, but we typically don't. Usually it's this one right here that we look at. Another parameter we would calculate is the average force. So I'm just going to draw this over like this. We just calculate the mathematical average of all these data points. Now, interestingly, body weight, I can put body weight anywhere. Body weight is not the average force. Like if you take the average of all this, it's not going to be body weight. Okay, body weight is a separate value on here, and depending on how fast we're running, this peak can go up, can go down, it can even be lower than body weight at times. This peak will always be greater than body weight, and where this body weight falls relative to this value right here, it can sometimes be this value can be above or below that. And I should identify that one right here. This right here is F min. I'm running out of spots to write here because I'm going to have to put it right here. That's the minimum. We don't always put a lot of meaning into this minimum force, but it is a force that helps us distinguish between F1 and F2. If there's no F min, that means there's no F1. So it's a nice computational parameter to pull out. All right, so we have average, we have F2, and then F1. And one other key parameter to quantifying this ground reaction force is called impulse. Impulse is the area under the force versus time plot. Impulse. And I'm going to shade this in, and what we would do is actually calculate the entire area under this curve. Now, mathematically, how do you do that? And I actually have another video that I'll have out there that you can watch on how to calculate that area. But impulse, we know, is force times time. So we have force times time, and the area under this curve represents that impulse. And if we're doing a running kinetic analysis, we may find calculating this impulse is important for some type of the analysis. Okay, so this is the vertical ground reaction force parameters that are important to be able to quantify the kinetics during running. Okay, thank you.